So hello everyone and welcome all of you to this session 1 of our new course that we are starting from today. So is my voice audible to all of you? So all of you are
Yes,
on
sir.
mute? Okay. So all of you will be on mute and you will not also be able to turn on your videos. So if you want to communicate, the way to communicate would be through typing in whatever you want to say in the comment box. So that is how we always do when we are conducting live sessions. And I think it is convenient for the entire audience uh, in this way. Okay. So you can type in whatever you want, and we generally monitor the chat box. So if you have any questions, you just have to type in, and I'll be keeping a watch on the comment section and will answer whenever it is appropriate. So welcome once again to this first session of a new course and a new series that we have started, and we are calling it as the project design series. So in this series, we will be doing a lot of projects, RCC projects, structural steel projects, and projects from the real life. We would be taking and we would be designing them in these course series. So the first course of this series, we are starting with a project on the residential bungalow. So let us start then. And before I start, let me just quickly look at the agenda that we are going to cover today. So some points I already had talked in the introductory session, but I just thought I will put it here once again. So it's very important to understand that what is expected from a structural engineer. We all are practicing engineers, so we have to understand this thing, and we have to realize this thing, that what is expected out of us, what our clients expect, or what our seniors expect from us. This is what I will try to discuss first. Then I will just talk about the various phases of a project. So when I talk about a project, it does not only involve design, but it involves a lot of other things as well. So I'll just talk about that. What is meant by the word design when I say design, because our course name is Project Design Series. So what is design? I'll just highlight that also. And then we will go to the steps that we will be incorporating for this project in this course. And we will then go to the details of the project. So today is the session 1. It's not going to be a highly technical discussion today. We will have an overall perspective in today's session. So let us go ahead and see what we have. Yes. So many structural engineers, all of us are engineers, some are practicing engineers, some are working somewhere, but all of us are civil structural engineers. So many times we face this question that we know the theory of engineering, structural engineering, because we have completed 4 years of engineering or 2 years of post graduation, or we have been involved in a lot of studying the civil structural engineering subjects, but we feel that we are not confident of applying it for an actual project. Okay. So even after studying 40 subjects or 50 subjects in our curriculum, we feel that we don't feel the confidence required for dealing with an actual project. I talk with many engineers, they say that uh, they are fearful of giving design or drawings for a project because they don't know whether what they are doing is correct or not, or what is the process to do a particular project. They are not sure about it. So this is often felt by civil engineers, or it is often felt by the engineers that they want to apply their knowledge for a hands-on project. Because in our curriculum, see, we are taught about beam in a different, let's say in RCC design, we are taught about beam, we are taught about column design, we are taught about footings, but we are never taught what to do for an entire building, right? In all our course curriculum, in graduation, post-graduation, nobody takes an entire building and teaches us from top to bottom. They will be talking about piecemeal fashion, beam, column, footing, etc. But uh, how to do it for an entire project, that link I think is missing in all our course curriculum. And it's not only with normal colleges, but also good colleges in India or abroad. The same problem everyone faces, that uh, the there is no avenue to apply the knowledge. So I and my wife Akanksha, who we are classmates from IIT Roorkee, and we did our post graduation over there in structural engineering. So even after doing structural engineering, we were not very sure on how to do an entire project ourselves. So that is the scenario that is there, and therefore to equip ourselves with real world challenges of structural design project, because we don't get to learn these things in our colleges or in our curriculum, we thought that a platform like this should be created. Okay, so that is the reason for starting these types of course series. Now, what is expected of a structural engineer? I had taken this slide in the introductory session also, but once again I am repeating because I think it is important to discuss this issue. So as a structural engineer, if you are practicing somewhere, or if you are going to join as a professional structural engineer, there are some skills that you need to have, and there are some things that is expected out of you. So it is expected that you have a thorough understanding. This is important, and this is, I have written it as the first uh, important thing that as an engineer you should know, that is thorough understanding of fundamentals. All right, what we can call it as the first principles. So this is extremely important, and you must know it. There is no alternate to this thing, that your fundamentals should be absolutely clear. And for that, you need to, even if you need to go back and study books, or you need to go back and study the basic subjects like theory of structures, or if you need to study subjects like stress strain analysis, all those things are absolutely essential. All right, so thorough understanding of fundamentals is absolutely essential. You should have a very good understanding of the various structural system and their load path. So what do I mean by various structural system? For example, if I have a beam, column, moment frame, okay, so this will be my structural system with a slab, of course. So if we have a slab, beam, column, moment frame, this is our structural system. It is very important for us to understand that what will be a load path for this system. Why it is important to understand the load path? Because depending on the load path, we carry out the design, right? So for example, if I have a slab beam, column, moment frame, what will be the load path? So the load path will be, for gravity loads, it will be that the load will first come on slab. Let's say I'm talking about the floor loads. From slab, it will go to beam, and from beam, it goes to column, and from column, we will transfer it to, let's say, our foundation system. So this is the load path. It's very important that you understand the load path, and then in accordance with the load path, you design your element. So each element has to be designed as per its load path, and for the correct estimation of loads, that how much load will act on slab, from slab how much load will be transferred to beam, and so on. It's important that the load path is well understood. So therefore I have included this point. All these points that I have written over here, we have actually taken them from the various recruitment notices or from the various documents of multinational and international companies, uh, where the recruitment documents that ask for the that ask for the roles and responsibilities, expectation from an engineer. So from there we have taken all these points, and I think all these points are quite important. So then as an engineer, uh, more importantly as a design engineer, we have to follow certain codes or standard practices for design. Okay, so we have to have a good knowledge of relevant Indian, because I'm writing in the Indian context, or international standards, whatever is applicable. Okay, so there is no escaping. You have to have good understanding and knowledge of the relevant Indian standards. Why? Because as designers, we are expected to follow certain minimum design norms as per these standards. So this knowledge is very important. Just like a lawyer has to know the, let's say, the CRPC or IPC, the Indian Penal Code, or the criminal procedures or whatever. Similarly, we as engineers have to understand and know the relevant Indian standards. Okay. So there are thousands of standards on civil engineering, Indian standards. We don't need to know all of them, but at least the basic standards we should be aware of. And you should also develop a practice that you should be able to read a new standard, and you should try to make meaning out of it, or you should be capable enough of understanding what is written in a particular standard. Okay, so let's say tomorrow you are involved in certain project where you have to do some design related to bricks. You have to use clay bricks, and you have to use them for a structural design. So then you go and search for the Indian standard for it. Let's say the Indian standard is something, I don't recall the name. So let's say even if you have not read that standard before, you should develop a habit of uh, reading the standard and trying to understand from it. Okay, because every time you will not get someone to explain the code to you. So you should develop this habit that you should be able to, let's say you 4 5 6 whatever, 4 5 6 7, I'm just writing an imaginary number. So let's say the standard is IS 4567. You should have the capability of reading the standard and trying to understand from it. Unfortunately, for the Indian standards, there are not many explanatories that are available. Okay, or neither there are commentaries that are available for Indian standards. So in the American, for the American codes, there are good commentaries that are available with the code themselves. But for the Indian standards, unfortunately, commentary is not available. So sometimes it becomes difficult to grasp the meaning from it, but still you need to develop that capability. Okay, so develop this habit that try to read the Indian standards, uh, and try to also search for unknown standards and just learn from them. Then, so for us, let's say if I write in the Indian perspective, it would be 456 that is required, the IS 800 that should be understood, the IS 875, IS, I would say 1893, IS 13920. These are some of the basic design standards that you should be aware of. Okay. What is 875 for? Yes, in the Indian context, IS 875 stands for, so it is the general code for loading. Okay. All sorts of loading you may refer to 875. So 875 has various parts, part 1, 2, 3, 4, and 5. Okay. So part 1 is for dead loads, part 2 is for live loads, part 3 is for wind loads, part 4 uh, part 4 is for what? Part 5 is for special loads and load combinations. Part 4, I think, is for snow loads. Very good. Mr. Mukesh is saying part 4 is for snow loads. The corresponding standard in the American context is the ASCE 7. Okay. So just like we have IS 875, they have the ASCE 7 for load calculation. IS 800 is for steel design. The corresponding American standard is, I think, AISC 360. 456 is for, all of you know, RCC design. And the corresponding American standard, if I had to write, would be ACI 318. Okay. IS 1893 is for seismic load calculations and seismic load application. Again, it has how many parts? The 1893 has how many parts? So 1893 has 5 parts right now, and there is a draft for the 6th part also. Okay, there is a draft out for the 6th part also. In the American context, it is the ASC 7 that deals with the earthquake loads as well. And the 13920 is for the ductile design and detailing of RCC. So in the American distinct context, it is the ACI 318 that deals with the ductile design and detailing also. So you should be aware of at least these basic codes as a practicing engineer. Now, in addition to this, you should have a deep understanding and a practical working experience of using software. Okay. And softwares like ETABS or SAFE or STAT, these are some of the basic software that as an engineer you should know. Now I have seen people who are I have seen generally 3 types of people, 3 types of engineers. There are some old means old by age. So there will be some senior engineers who say that software is all rubbish, right? They give very little importance to software. So they will only say that manual calculations are the best and software is rubbish, right? Have you met such people? So they will have all sorts of names for software, that this is bad, STAT is poor, ETABS is worthless, there is no value of using software, manual calculation is the best. In our time, we used to do manual calculations for 30-story building and all those sorts of things. Okay. Then you will find some very young engineers, young by age, of course. So who only rely on the software. Okay. So they are like computer operators, or they are almost like electrical engineers who can only work if the power supply of their computer is on. If the power supply of computer is switched off, they no longer remain engineers. Okay. So we don't want to be like them also, only relying on software. What is a good approach? A good approach is the middle path, where we have good understanding of manual procedures also. Okay. And we have good understanding of the software working also. So as engineers, I should think this is the middle path that we should have. We should not be totally dependent on manual calculations, or we should not be totally dependent on the software to help us out. We should have a mix of both. All right. So it's extremely important to have a deep understanding and experience of using these software. Now, we often hear about this, and I have also told this, that let's say I take this example of the Golden Gate Bridge. Okay. Or if I take the example of the Empire State Building. So these were built in which year? These were built in, hello. These were built in which year? So the Empire State Building or the Golden Gate Bridge. So these were built sometime in 1930s. Okay. So in 1930s, you did not even have the moment distribution method developed quite well. Forget about computers or forget about the matrix method. You did not even have the moment distribution method developed. So then how were they able to design and provide these structures? By the basic hand calculations and by the basic understanding. So now, if you do these designs today, let's say if you have to build a bridge like Golden Gate Bridge today, or if you have to design a building like Empire State Building today, what you will be able to do? So in my view, you will be able to save at least 10 to 15% on the cost of material. Okay. In my view, if you do a design today, you will be able to achieve at least 10 to 15% saving for materials, or for the sizes of, no, so sorry, 10 to 15% saving you will be able to achieve by saving the material that you will be putting in. So why this saving you are able to achieve? Because you have better understanding of the behavior, and because you have got better tools like these software tools. So you have got better tools to do your work. All right. So in my view, you will be able to achieve, or you will be able to have considerable saving now. So software is not bad, but the incessant use of software is bad. Use of software without understanding is bad. Okay. So try to develop a deep understanding of softwares and use it to your advantage. There's no, so I don't agree with people who put bad names to the software. That is not the right way to do it. Okay. Yes. So which softwares as engineers you should be knowing? So in my view, the knowledge of ETABS and StatPro is essential these days. In the Indian context, if you see, structural engineers use StatPro for their designs, but increasingly these days, and with the multi-story buildings being built more and more in India, so these days you see structural engineers comfortable with, or they ask ETABS also from the engineers. Okay. So knowledge of ETABS, StatPro has become almost essential these days for the structural engineers. In addition, it's always helpful if you have additional knowledge of software like SAFE, which is a very good software for foundation design and slab system design. So you should have some knowledge of that also. Then Excel, of course, is the all-time greatest ever software built, Microsoft Excel. Excel does so many works for so many different types of people, not only engineers. Excel plays such an important role for almost all professional people, whether they are engineers or doctors or lawyers or financial analysts or business managers. So Excel is an excellent tool. I think it's my one of the all-time favorite tool, Microsoft Excel. AutoCAD or any CAD software, any computer-aided drawing software. As an engineer, you may think that this is the work of a draftsperson to make drawings. It's not your work as an engineer to be making drawings. But then it is always helpful for you as an engineer also that you should have some good knowledge of AutoCAD. So you may not be required to make your own drawings, because you can always hire draftsperson to do this work. Or if you're working in some office, they will always have some draftsperson to make the drawings. And as an engineer, you will be associated, or you will be required to do the design and estimation and all those things. But still, I would say that you should have the basic knowledge of drawing preparation using AutoCAD. That is important for us as engineers. Okay. And not only 2D, in my view, you should also learn the AutoCAD 3D. Okay. And these days, increasingly, Revit is also being used with the advent of BIM. Revit is also being used increasingly these days. So the Revit models usually engineers themselves prepare. And I mean, you can always have draftsperson to do this, but engineers also do this work these days. So these softwares you should know. And then there are some secondary software, like in the Indian scenario, there is a software called as RCDC, which is used for the quick design and detailing. Okay, so you may use some secondary softwares like these. So in my view, these softwares, if you know, it helps you in the design engineering work. How many of you know good AutoCAD also? When I say AutoCAD, it's a type of a CAD software. There are several different CAD softwares these days. You have the uh, CAD. I mean, what are the other CAD softwares that you have? AutoCAD is of course the most popular, but there are Plan CAD and I think WinCAD and many different softwares these days you have. How many of you know proper or how many of you have good knowledge of AutoCAD or any CAD software? Drafting level experience? Yes, Mr. Ahmed Zubair is saying only AutoCAD, he knows. Right. So it's good to have the knowledge of AutoCAD. And if you have a drafting level experience, that is even better. Anyway, then what else is expected? So we have to have the ability as engineer to design and detail various elements, either using software or by using manual calculations. Okay, or sometimes a mix of both. So as an engineer, of course, this is our primary job, that we should know how to design and detail various elements. They may be steel, they may be RCC. So either by using the software output, either by taking output from the software, or through manual calculations, or through the use of both. This ability we should have. Then we should have the ability, if not to prepare, at least we should have the basic knowledge about the drawing development and the details that you have to put in any drawing. Because finally, the language of structural engineering is through use of drawings. So you have to have some basic knowledge for this. Then the next thing is that you should know how to prepare bill of quantities or how to prepare estimates, and you should also know how to prepare the design calculation reports. So these things, you may think that they are not directly related to structural design, or they are not directly the work of a structural engineer, but these are very important things when it comes to a project. Importantly, this BOQ preparation, because if you do not have the bill of quantities, you will not understand the quantum of the work, and it will be very difficult for the execution agency to understand how much work is involved. It will be difficult for the client to understand what is going to be the expected cost. So BOQ preparation is extremely important. You should properly understand how to prepare the bill of quantities. You should understand about the specification of each item. You should understand about the rate analysis. Okay. You should understand about the methods of measurement of a particular item. So all these things also, as a structural engineer, you should understand. Generally in the engineering, we are taught, I think, one or two subjects based on this. But when you start working, you get to learn about these things more. Design calculation report, it's required sometimes when you are doing projects for the government agencies. So they ask you to prepare the design reports for the project, or if you are doing some important project and if you have to get it peer reviewed or third party checking, then you may have to prepare some design reports. Okay. And our work as an engineer is not only related to our own desk or our own project or only our part, but we should be good at coordination either with the client or with the other disciplines. So because a building involves lot of parallel trades like architectural, mechanical, electrical, plumbing, HVAC, okay, firefighting. So there are a lot of agencies involved. in a building and more agencies involved in a commercial building. So as a structural engineer, you should be able to coordinate and you should be able to discuss your matter in a proper way with the other agencies involved. Okay. So this skill cannot be taught. I mean, it will come only with time and experience or by observing your seniors or other professionals. But this is also an important role as a structural engineer that we have to carry out. And finally, we should have good written and verbal communication skills because we should be able to communicate our message properly across. Either it is written. So if you are working for some professional firms, there is a lot of documentation that you have to do. There is a lot of correspondence that you have to do for projects. You have to take part in a lot of meetings, etc. So you should have good verbal, that means speaking skills, and you should have good written skills also for effective and proper communication. So all these are the expectation out of a structural engineer. In this course, we are going to, through this course, we will highlight these issues that are required to be known for an engineer. Okay. So these issues we will be addressing, I would say, through this course. Okay, moving ahead. So this slide was a repeat from the slide that was shown in the introductory session also. Now we come to this discussion that if I talk about any project, what do you think are the phases of a project? So if your client comes to you and he or she says that they want to build a factory, okay, or they want to make a commercial shopping complex, a mall building. So how will you take that project ahead? What do you think should be the first step when you have to do such a project? What do you think should be the first step? Yes, anyone would like to write their views? What do you think should be the first step when you have to start any project? So as an engineer or as a technocrat, what will be the first step? So first step, Mr. Zubair is saying planning, architectural planning. Isha is saying architectural planning. So will you directly jump to architectural planning? Will you directly jump to the architectural planning? So first step, it is extremely important to understand the requirement. Yes, as Mr. Mukesh is saying, it is extremely important to understand the requirement of the client. Okay. So why it is important to understand the requirement of the client? Because if you do not understand the requirements properly, it will not be possible for you directly to start with any sort of planning. Okay. So a client may come to you and they may say that they want to develop a shopping complex, let's say. Okay. So now it's your duty to understand. It's your duty to understand that what sort of requirements they have in their mind. Okay. Or let's say a client wants to make a educational institution. He or she wants to make a college, and they have appointed you as their architectural and structural engineer or consultant. So they want to construct a college. So you have to understand, or you have to ask from your client that what is the requirement that they have, what is in their mind. This step is extremely important. Many projects face a lot of difficulties or issues later on because the requirement of client changes midway, isn't it? I have seen many projects getting delayed or many projects getting cancelled or many projects running into cost overruns. Why? Because the client requirement changed midway. So they wanted to construct, let's say, a mall. Midway, they thought that no, I think hospital is a better proposition. Okay. So then you have the frame ready, structure ready, but now the client is thinking that we want to now make a hospital out of it. Or midway, he or she may think, your client may think that I think this G+4 is not a good idea. Let's have another floor added to it. So these types of things, why do they happen? Because the requirements are not properly frozen before starting with the architectural planning. So it's very important for us to understand the requirements from the client. The client may be building, let's say a client comes to you and he or she wants to make a, as I said, he or she wants to make a house. All right. Now, generally, as a person, we make house for our living maybe once or twice in our lifetime, right? So as a client, he may not have the necessary experience of making houses. It is his or her first time that they are making a house for their own. And they may not be from a technical profession. Let's say they are a doctor family, so they don't have much exposure to civil engineering or engineering or architectural planning. They are just people from other profession and they come to you. So as a technical consultant to your client, it's your duty to uh, to to completely or to fully take the requirements from them. Okay. Sometimes you may have to suggest the client and help the client in finalizing their requirements. Okay. So out of your own experience, because you as a consultant are doing several projects like these, you may have to help your client in finalizing their own requirements. So they may not know what they want. Okay. They may not know what they want. So it's your duty that you should be able to tell your client that no, I think in this house, this should be required, or you may not need a bedroom this big, or you need to have kitchen of this size. So these requirements, sometimes you have to help your clients to understand what they want. And of course, this comes only from experience of working. So freezing, finalizing requirements at the very first stage is very important. And if you want your project to go smoothly, the requirement should be frozen at the initial working stage. So once the requirements are frozen, then what will be the next step? So then the next step can come the site investigations. All right. Now, why have I written site investigation? So as an engineer, as an architect, as a technical person, it's extremely important to visit the site first. Okay. Hello. So when you visit a particular site, you get to know the first hand, you get to note down the first hand information from there. There are a lot of issues that every site has. So if you have made a site visit, it will actually help you in doing some better planning. Okay. And it may help you to frame the requirements also in a better way. So even though site investigations or site visit you may do later, but still it's very important part of your project. Many engineers skip going on sites, and more so with the multinational companies that are there in the job market. The site, let's say you are sitting in Mumbai, let's say you're sitting in Mumbai and you're working for some company and your project is in South Africa. So it may not be possible for you to visit the site. So that is a severe handicap that we face of not being able to visit the site. And if possible, I would say you should visit your site before starting any project. Okay. Not only visiting the site, but also carrying out some preliminary site investigations is very important. Carrying out preliminary site investigations, or I will give you one more example. Suppose you have a flat terrain. Okay. Suppose you have a flat terrain. I'll give you one more example of how visiting the site may impact your planning also. And suppose you have a terrain like this. All right. Suppose you have a undulated terrain. So do you think that your architectural planning may be different for this flat terrain and for this terrain having undulations? What do you think? So for a flat terrain and for a terrain which has undulations, do you think that your planning may vary? Hello. So yes, you might vary your architectural planning. So on a flat terrain, the same structure may be built in a different way. On a undulated terrain, you may plan your structure in a different manner altogether. So it completely depends on the topography, on the site condition, on the environment where you are building. So it's very important that you have to understand your site before starting the planning. See, this may not be what I'm telling you, this may not be applicable for a small residential bungalow. Okay. So for a residential bungalow, this site visit may not be that much applicable, because in a residential bungalow, you have a very limited space and you have many constraints over there. Okay. So for example, in a residential bungalow, if this is your plot and this is the road, let me just draw it. So in your residential bungalow, let's say this green is the road. I'm drawing the plan view. Okay. And this is your plot. This is your plot. And all across the plot, you have existing structures. So these all are existing structures all around your plot. Okay. And this is your own plot. And this is existing. So do you have much option when it comes to planning in residential bungalows like this? So the options are very limited. So for example, you have to have entry and exit from this side, isn't it? Can you have an entry exit from somewhere else? Can you have an entry exit from here? So you cannot have an entry exit from here because there is an existing structure. You cannot have entry exit from this side. You cannot have entry exit from this side. So the only possibility of entering or coming out from your building will be from this side, isn't it? So it may not be a suitable direction, let's say. It may not be a convenient direction to plan your entry exit from this direction, but there are very limited options that you have because of the restrictions that are there. Okay, just hold on, I'll be back. Yes, is my voice audible? Yes. So for a small site like this, or for a small plot like this may not be applicable. The site may have so many constraints that only one way of planning may be possible. Okay. But for a big project, let's say you are coming up with a big industrial project and it has a very big plot, and there are several buildings in your industrial project that you are setting up. Let's say you are setting up a dairy plant. All right. So then in a dairy plant, there are many units that you have to set up. Now the positioning of these units, or the placement of these units, or the various levels of these units, they can be better planned if you have the good knowledge of site. Do we agree? So you may plan this one over here, two over here, something like this, unit 2. Okay. And you may plan this on the basis of their material procurement, or on the basis of the production involved. So you may have the raw material coming from here, and let's say these are all the processes. Okay. Something like this. And finally, your finished good comes out and it is transported from here. So these big projects may be planned according to the site conditions and according to the site constraints and restrictions. But for small projects, you may not have the luxury of planning in this way. Anyway, so this is important. In addition to this, some preliminary site investigations are also extremely important. So again, for a big project, these preliminary site investigations may affect your planning, and they may affect your cost also. So investigations like the geotechnical investigation, or the contour survey, topographical survey, or what else? Or the hydrological survey, rainfall analysis. These all may be done for big projects, not for small projects. For a small project like the residential bungalow that we are doing, a geotechnical investigation may be sufficient enough. You may not be required to do other investigations. But for big projects, all these preliminary site investigations are necessary and important. So on the basis of these estimations, you can do a initial design, initial planning. Okay. And you can estimate. So here I am using the word estimate. You can estimate some preliminary quantity requirements. Okay. So why these preliminary quantities may be required? So these may be required for some cost estimation. So your client generally is interested in knowing what will be the cost involved for this project. All right. So you may say that how can I tell the cost before I finalize the design, before I calculate the steel and reinforcement and concrete quantities and the plumbing quantities and all those sort of things. So you may have a question that how to calculate the cost when you do not have anything finalized. So therefore, I have written this estimation over here. So how do you do estimation? So you do estimation on the basis of some thumb rules. So thumb rules means rules or guidelines that you have developed by having some experience of working on similar projects. For example, for a general construction these days in India, I am talking about, for a general RCC construction, residential or commercial construction, what is the per square feet cost that you take for civil construction? Civil and basic plumbing, basic electrical works, and basic interior finishing. So what is the per square foot cost that you take into estimation? So around Indore, we take around 1500 rupees per square feet. Okay. Mr. Mukesh and Mr. Vishwajit are saying they take around 1600. So maybe in Maharashtra, the rates are more, but in Indore, where we stay in Madhya Pradesh, in state of Madhya Pradesh, rupees 1500 per square feet gives us a decent finish, and it's a decent estimate for the civil construction, including basic finishing, basic interior, and basic electrical work. Okay. So this is a thumb rule. On basis of this thumb rule, you can estimate the civil cost for a general building which has particular size. So still you have not done any design, you have not finalized any sizes, but just this is based on the thumb rules. So on the basis of these thumb rules, you can work out the quantities and cost, and you can do some initial planning. So then after initial planning, you may discuss with your clients and your project may get finalized and approved. So you will notice that almost 60 to 70% of project for a practicing engineer, they will finish at this stage only. Okay, because you give some cost to the client and the client, looking at such high cost, runs away and we do not get the project, isn't it? It often happens that this is only at the inquiry stage, and maybe 2 or 3 out of 10 projects will finish at this stage itself. They will not go ahead because the client runs away. So if the client approves the cost, if the client approves the planning, then your project may get finalized and approved. And after approval and finalization, then you may do the detailed design. Okay. So when I write the detailed design, it involves the architectural and structural design both. All right. So initially, even architects, what they do is that they may prepare some proposals, working plans, or some basic proposals they will prepare. And those basic proposals will then be discussed with the client. If the client approves, then we will start preparing the final proposals, final drawings, final designs, then maybe started. So after detailed designing, we will be doing the detailed drawing work and detailed drawing development. So whether you are an architect or a structural engineer or a HVAC consultant, in all these cases, we will have to prepare some sort of drawings. And after our design is done, we will have to proceed to prepare the drawings and the further detailing. Okay. Then what is the next step? So once these drawings and details are ready, then we can prepare the bill of quantities. Okay. You will notice that initially I had written estimate over here because it was just an estimation. And now we are able to prepare the actual bill of quantity. Why? Because now we have the drawing and we have everything finalized. So on the basis of this finalized drawing and design, we can now prepare the actual bill of quantities. Okay. So this will be the next step that you have to do. Then the development of project plan and project schedules. So you might have seen people who are involved only in the project planning. When I say project plan, it's the time and resource planning. Okay, time planning and resource planning. That resource may be people, that resource may be material, that resource may be money, the resource may be labor, any resource. So development of project plan and project schedule. This is another step or the next step that you have to do. Then once this is done, what you will do next? So then you will look for some contracting agency who will execute this work on site for you. Then comes this step of project execution. Extremely important because till now everything was on paper. Now for the first time it is getting translated to reality. So project execution. This entire process of execution will involve the management of the project properly. And once the project management is done, once you are managing your project well, then comes the final commissioning. So you will see so many so many phases of project are required, or the project has to go through so many phases before it can be completed. All right. Now, each phase in itself or each step in itself is so vast that there are dedicated agencies who only do part of this work, right? For example, there are agencies who only do the, let's say there will be an agency who will only do the geotechnical exploration, correct? So you will find good testing labs who only do the site investigation work, okay? Who will do the geotechnical exploration, or who will do the material testing, or these sorts of things. So they will not do anything else. They will only do this work. Yes or no? Or there will be agencies who only do the surveying, who do the remote sensing based survey, or who will do the physical survey. So there will be agencies doing only the surveying part. There will be agencies who will only do the design part. There will be agencies, special agencies who do only the estimation. There will be agencies who are only involved in the project management consultancy. Okay, so this work and this work together, it is clubbed under the project management consultancy. There may be agencies who are only interested or who are only involved in the tender processing or tender bid processing management. Okay, what do you mean by bid processing? So for big projects, because there are many parties involved, you have to float a lot of tenders, you have to involve yourselves in a lot of negotiations. There is a lot of what should I say, contractual things that are involved. So there are specialized agencies who only work for in the field of tender management or bid processing. Of course, there are agencies who only work as contracting agencies, who only execute the project. So you'll see that so many different agencies are involved for a project, right? So many different agencies are involved. And I will say that the design and the structural design and structural drawing preparation, structural design and drawing preparation, this only is a very small part of the entire project. I will say it's only 10 to 15% part of your entire project. Okay. So this detailed design work that we are going to do for this, and this much thing that we are going to do in this course, it involves actually a very small part of the big project. Do you get it? Hello. I hope this is making sense. Yeah. So we will be mainly focusing on these issues, but if you are working engineers, working professionals, you can try to explore these opportunities also. Okay. You can try to explore the other opportunities also by doing other works. So you may think of starting a project management and execution agency. You may start a contracting agency or an execution agency of your own. You may involve yourselves in the bid process management and tender preparation. So you may think of diversifying, or you may think of going into these fields as well. Right now, we will be focusing on this part, which is the design and detailing and quantity estimation part of a project. And as I told you, it is only 10 to 15% of the total project cost. All right. Right. So these are the phases of project. Now, what are we going to do? I think okay, let me just take it. I just wanted to tell you that when we use the word design, or I think I'll take this slide later. So for our project that we are going to do, as I told you, we'll be focusing more on the architectural design and structural design part of the project. We will not be talking about investigations, or I will not be talking about the surveys, or I will not be talking about the project planning and scheduling. So those aspects I will not be talking about. So we'll be mainly focusing on the architectural and structural design part. So for our project in this course, what will be the steps involved? Let us try to have a look. How will we approach this project? So we will start with the understanding of architectural space planning and the architectural concept. So as I had told you that the architect for this project would be joining us, and he would be explaining us that what was his brief, what was the brief given to him by the client, and how did he do the architectural space planning, how did he understand and finalize the requirements, and how did he come up with a concept. So this we will start with. This will be the first step in our project that we will take up. Remember, we are only going to focus on the architectural and structural design parts and not the other phases of the project. So we'll start with this. Once this is done, then we will plan the structural framing system. What I am doing right now, I am telling you that what will be the steps involved for the RCC residential bungalow project, and how will we take our project ahead. So this will be the starting step. Then once we understand about the architectural space planning and the concepts involved, we will then move to planning of structural framing system. What do I mean by planning of structural framing system? Yes, anyone? So planning of structural framing system, we will not directly jump to ETABS or STAD and open a model. No, we will not directly jump to ETABS or STAD and start making some model. That is not how we do it. Planning of structural framing system means we have to first plan what will be our framing system, whether you will be using a flat slab system, or you will be using shear walls, or you will be using a steel frame, or you will be using a load bearing system. What you will be using, that has to be finalized first. So in our case, let's say we will be going ahead with a movement frame. So movement frame means we will have a RCC slab beam column system. Okay. So movement frame means we will have a RCC slab. Just a minute. We will have a slab beam column system. So once we decide this, then we have to decide the position of columns. We have to decide the position of columns and beams. Slab position, of course, it does not matter because slab you have to place anyway, covering the entire floor. So slab position is not important, but to finalize the position of beam and column, it is very essential. Okay. So you have to have your columns placed in such a way that they do not obstruct with the architectural planning, or they do not obstruct with the space utilization, and your beams should also be planned in a way that they do not obstruct the overall aesthetic view, and they do not obstruct the overall space utilization. So this is extremely important, and this skill to finalize or to place columns, beams, to come up with a structural system, this only comes with experience. Okay. But this is extremely essential step. So you directly do not jump to a software and start preparing models. First, you have to finalize this. Okay. So this will be our second step for the project. Once we understand about the architectural space planning and concept, Then we will move on to the planning of structural framing system, deciding the position of beam, column, slab, etc. Once this is done, then we will model the superstructure on ETABS. So this is the process that we will be adopting in the course that we have started. So then we will do the modeling on ETABS. In this course, we are going to use only ETABS, but if you have knowledge, you may do the same thing using StatPro or any other software. Pro, what is the name? Pro 3D, no, Prota Structures. I'm forgetting. Any such software, commercially available software, you may use for doing the modeling. I personally like ETABS because it is a good software. It provides you a lot of options and features. So I personally think that ETABS is a pretty good software to use. So this will be our third step, doing the modeling of superstructure on ETABS. After the modeling, what we will do? So we will do the load calculations and we will apply the load on the model. So load calculations we will do for gravity load and for lateral load. This is extremely important step. And I have seen that in course in your colleges, in your studies, generally there is no subject or there is no discussion on load calculation, isn't it? You may read about wind and earthquake, that is different, but generally there is not a proper discussion that we have for load calculations. Okay, in my view, it should be a different subject taught at undergraduate level on how to properly calculate the loads and how to apply the loads on a computer model. Okay, this is a very important skill that is required. So we will be doing this as our next step. Then after this, once our loads are calculated and applied, then what we will do? Then we will do the analysis. So any software that you use, you generally follow these steps, that you do the modeling, you do the loading. After loading, you will do the analysis. And after analysis, you do the design. So for any structure, whether it's RCC or steel, these are the general process that we follow in our software. So that is what is being written over here, that first we will calculate the load. We will prepare the model first, then we will calculate the load and apply the load. Then we will go for the analysis. So analysis means finding out the bending moment, shear force, axial forces, etc. Okay. So once this analysis is done, then what we will do? So after doing the analysis, then we will do certain design iterations. I will explain later what is the meaning of design iteration. So we'll do design iterations and we will try to finalize the sizes in an optimum manner. So we are designers. We don't want to provide unsafe structure, and we also do not want to provide oversafe structures. All right. So for example, if I have a ground structure, or G+1 structure with normal spans, let's say it's 4 meter by 4 meter, and normal spans, normal loading, everything. So if I provide a 1000 mm by 1000 mm column, do you think this will work? Will it fail? What do you think? If this is a G+1 structure and I don't carry out any design as such, I just provide this particular size, you think it will fail? So it will be extremely stable. It will be very strong. Okay. It will be very, very strong structure. Of course, subjected to general loading. So this structure, let's say, is subjected to general loading, not much wind, not much earthquake, very, very strong. Okay, and heights are also normal, 3 meter floor heights. So this is not going to fail. So this is very safe. But is it optimum? This is very safe, but is it optimum? No. So it's not optimum. It's not value for money. Okay. So as structural engineers, we don't have to finalize the safe, or we don't have to come up with safe structures. We have to design sizes which are optimum. Optimum means neither unsafe, neither extremely safe. They have to be just right. Okay, that is the meaning of the word optimum. So we will do design iterations to finalize and to come up with optimum sizes. This is very important. And this is where the skill of structural engineer lies in coming up with the optimum sizes. Then after this step, what we will do, these are all the steps that we'll follow for our project. So once this is done, once we optimize the size, once the concrete size has been optimized, then we'll find out the reinforcement using either some software like RCDC or ETABS itself or some Excel sheets. We'll find out the reinforcement requirement. All right. Then once the superstructure is done, we will go for the substructure or foundation. So we will export these superstructure reactions to another software called as SAFE. This is the procedure we are going to follow for this project. So we will export the superstructure to SAFE. So that means till now we have designed till this level. If this was the elevation of my structure, and this is, let's say, soil, and this is where you have provided a column support. So first you will design your structure till this and find out the reinforcements, everything, etc. So you will design till this level. Then once the design has been done till this level, then you will take these reactions, export it to another software, and then design the foundation for it. Do you get it? So in the foundation design, again, the same steps have to be used. We will have to analyze first, then you will have to set the optimum size, then you will have to finalize the sizes and work out the reinforcements. So this is what we will be doing. Once our superstructure is done, then we will export the reactions to SAFE and we will do the footing design over there. So I've written modeling analysis of foundation using SAFE. Is it clear to all of you? Yes. And then once this is done, as I said, we will then finalize the foundation reinforcement. Again, using either some software or through manual calculations, we will finalize the reinforcement requirement. Once your superstructure substructure is ready, then you can go to the drawing development using AutoCAD. So for this project, we will have the introduction of drawing development. We will not sit over here and draft the entire project. If you want to do so, you can do it at your own end. But here I will be talking more about the development. We'll not sit here and make drawings over here because that will lead to unnecessary wastage of our time. So, but we will understand how the drawing has to be developed. That we will, of course, be doing. Once the drawings have been developed, then we will do what? Just a minute. Yes. So once the drawing have been developed, then what we will do? Then we will go for the preparation of quantities using Excel. And then finally, we will prepare the design report. So these are the steps that we are going to follow. So you will notice that these are the planning related steps. This is the from here to here, I will say. These are the steps for design. This is the step for drawing detailing. This is the step for quantity estimation. And then this is the step for calculation report. So this is the sequence of steps that we will be following for this particular project. And not only for this project, any project that you do, whether it is a RCC project, it is a steel project, whatever it is, these are generally the steps that we follow. Okay. Okay. Any question or confusion? Hello. Okay. And then finally for today, the details of our project. I have shown this earlier also. So the project that we are going to do is a residential bungalow. It has a 2,500 square feet ground coverage. And you will see big room sizes, spacious sizes. The architecture looks modern. And the structural system that has been adopted is a RCC movement frame. And as engineers, we'll be designing it for the gravity load and the earthquake load. And for foundation, we'll be providing eccentric footings. Why eccentric footings? Because you will see that many columns are on the plot boundary. So you may not be able to provide concentric footings for them. So eccentric footings may have to be provided. And as an alternative, just for further discussions, we will be also talking about a substitution with pile and pile caps. All right. And then these are the project details that I've shown you earlier also. So this is the AutoCAD drawing. This is the ground floor plan and first floor plan, roof floor plan. I'll just show you an AutoCAD. This is the SketchUp model prepared by the architect. So SketchUp is a software by the, I think it has been developed by Google. So it's a very easy to use software and very effective for making these types of models. And this is the rendered view of the finished project. So this is how the brief has been submitted to client. Whether or not it comes out this way, it's a different thing altogether. But at least this is the brief, or this is the, not brief, this is the submission to the client for the rendered view. Okay. I'll just show you the AutoCAD drawing. We'll be discussing it tomorrow also. But let me just show you. Can you see the AutoCAD drawing? So this is the floor plan, ground floor plan. There is an entrance veranda over here. This is the circulation lobby. There is an elevator, a bedroom over here. Then there is a toilet and a walk-in closet. This is the dining space. This is the living room. This is a bedroom at the back. And this is one kitchen that they have. At the back of kitchen, they have a wash area. And then this is a big lawn that they have developed. So this is the ground floor. Then your first floor looks like this. So this is the circulation lobby. This is your lift. This is your master bedroom. This is your walk-in closet and toilet. This is another bedroom over here. An attached walk-in closet and toilet for this bedroom also. This is another bedroom 4. It also has a walk-in closet and a toilet. And you have got bedroom 5. This also has a walk-in closet and a toilet. So you'll notice all bedrooms have attached toilets to them. Okay. All bedrooms are having attached toilets to them. And then there is an open space over here. So this is a covered sit out at the first floor and a terrace garden at the first floor. All right. Then, so this is the first floor. Then at the top floor, you have an open terrace, and plus you have a storeroom and you have a toilet. So this storeroom may be used for the staff quarter also, and they have got a toilet probably to be used by the staff person. So this is how they have planned it. So this is the AutoCAD drawing. I'll upload this AutoCAD drawing on the portal for you to study. All right. Yes. And so this is all what I had to tell you today. Now tomorrow what will happen? Tomorrow we will have a session. Tomorrow we will have a session by the project architect. So architect Darpan Bhalerao, who is the project architect for this, he will be joining us tomorrow, and he will tell us about the requirements that were given by the client to him. Okay, so he'll first talk about the requirements given to him. Then he will tell us that how the concept was created and how the space planning was done. Okay, so all these issues he will be talking about. He will also be talking about the municipal restrictions. He will be also talking about the municipal town and country planning rules that have to be followed for these types of planning. So this is what we will be doing tomorrow. Okay. Yes. So any queries from your side? Mr. Mukesh had a question. He was asking that for small projects, people or the client don't want to pay for the soil investigation, then how to proceed for the footing design. Yeah, so this is an important problem that almost all of us face, that for a small project, nobody is ready to do the soil investigation, because if your soil investigation costs you 25 to 30,000 rupees, and let's say the design engineer's fee is 25,000. So the client says that why I need to do soil investigation, and that is a real problem that we face. So in such cases, the only way to do it is either you do an open pit. Okay, so you can always go for an open pit. You excavate 8 to 10 feet inside and try to see what is the strata that you have. You can talk to the neighboring owners or the neighboring or the people who live on the neighboring plots to get an idea about the type of soil that you get over here. But an open pit is always the best thing. Try to have an open pit, and from the local working, you have a general value that this should be a minimum bearing capacity that you might get. So for example, over here, if we encounter a yellow soil where we live, so for a yellow soil, we get a bearing capacity of around 15 to 18 tons per square meter. Okay, so those sorts of things you should know, and they will only come out of experience. So yes, so do an open pit on these types of site. Open pit, you can use any earth moving equipment. So make a pit of 8 to 10 feet deep and try to see what is the strata that you're getting. Yes, so all of you who have registered, they will be added to our online portal. And how to watch the sessions on online portal, I'll just demonstrate to you. So when you log on to online portal, you will see a course like this added to your account. So how do I show you? So for example, something like this. All right. So when you will go online to the website AuxEn.PDC-RCC.com, you will see something like this, and you will get to this My Courses. And in My Courses, you will be able to see the session like this, and you will find the daily session uploaded over here. Do you get it? Hello. So the daily sessions will be uploaded over here. So for example, right now you can see only the introductory session, but then later you will see the session 1, session 2, and so on. All right. So this is how you will be. Those who are going to join us and watch the online sessions later as self-paced learning, this is how they have to do it. Yes. Anything else? Okay. So what we are going to do tomorrow? Yeah. You can do it on Saturday. No problem. You can attend the session tomorrow, and yeah. So what are we going to do tomorrow? Tomorrow we will meet our architect for the project, and we will try to learn from him, and we will try to understand uh, his thought process and how he came up with this concept. So I think it will be an interesting discussion that we will have with him tomorrow. So that is all what I have for today. Thank you, and we'll see you tomorrow. Okay. Yes. Thank you so much. Bye bye.